Here's the ladder in the barn paradox. So we'll have two observers, one on top of the barn. There'll be another observer who's going to carry the ladder soon enough. But I just want to explain what the paradox is. And remember, paradox means a contradiction. Okay? So, here's the first thing. The ladder can just fit inside the barn. Okay? They're virtually the same length. Now for this one, the person on the barn has a little remote control that can send a flash of light left and right to sensors that control the doors. Now when the flash hits each sensor, it will close the door and open the door up again very quickly. So let's watch that. The barn doors can be closed and open again with a light signal to each door. Here we go. Closed, open. Let's watch it again. Okay, the barn and the ladder are the same length, so the ladder fits in. The barn doors can be open, then closed and open again with a light signal. Close, open. So that's what the light signal does. So the natural state of the doors is to be open. They just close when they get hit with a light signal, but then open again straight away. Right, so let's see what happens when the ladder tries to go through the barn. So here's the ladder. It's going to be moving towards the barn. Okay, what if the ladder's moving? Okay, now this person wouldn't be able to measure the ladder without adjusting their measuring device. So they measure contracted length. Okay, so let's watch that again. They measure contracted length because they have to adjust their measuring device to measure that ladder. Oh, hang on, let me do that again. Right, so the ladder fits just fine. If the ladder's moving, this observer will see it as a contracted length. Signal gets sent, reaches both sensors at the same time, doors close and open, but the ladder did fit inside the barn. Okay, so this observer says the ladder will fit. Now, here's an observer carrying the ladder. So they're saying the barn looks contracted to them because from their perspective, it's the barn that's moving. Okay, they can measure the ladder properly, but they can't measure the barn without adjusting their measuring device. Let's watch it again because I was talking a lot there. So the barn's going to move. This person sees the barn as being contracted. So now the ladder shouldn't fit. But look what happens. Simultaneity again. So from this observer's perspective, the barn doors don't close at the same time. Okay, so the barn's going to move to the left, which means that this pulse reaches this one first. Closes, opens. This one, close, open. So in fact, it's a bit of a trickery, isn't it? But to meet the criteria of will the ladder fit in the barn, all it's got to do is to be able to close both of the doors while the ladder's going through. So if they can close both of the doors while the ladder's going through, then the ladder fits in the barn, doesn't it? It's just that because of a lack of simultaneity, the barn moving to the left, the pulse of light moving to the right, this sensor was activated first, and this was activated later. Oop. So let's just have one more look at that one because that's the tricky part of it, just so you can get you're happy with the outcome of that, the solution to that seeming paradox. Close, open. Close, open. Good. Works. So that's the ladder in the barn paradox solved.